Now, you might be wondering, what happens when the equation is more complicated? For instance, what if there are two terms with variables, with the variable? Or what if the variable is embedded in a parentheses, deep inside the parentheses? Or what if a variable is on both sides of the equations, on both sides of the equal sign? What do we do then? Well, here's some examples of that. For instance, what if if the variable's in two different terms? Well, for all three of these situations, there's a common solution to all, and that is just simply simplify. Simplify the equation as much as you can. For instance, here, if I have 3x's and 2x's, that's 5x. Now it's an easy solve. X equals 12 divided by 5, or 2 2/5. Second thing, if the variable is embedded in a parenthesis, well, simply use your distribution property, multiply the number outside by the inside, get 6x minus 12 minus 9 equals 5. Take the 9 across, get 6x equals 14. Divide the 6 out and get 2 1/3. And you're done. So the first thing you did was simplify, do the distribution, and then go from there. Now, this brings up a good point, and that point is this. Why not divide the 3 out right away? Why not take that 3 and divide it out? So then we're going to get 2x minus 3, because this 3 canceled this 3. And then I've got 5/3, or let's make that 1 1/3. 1 2/3 would it be? Then watch what happens. I'm going to add 3 to both sides, and I get 2x equals 4 2/3. Then I'm going to divide by 2. Now, most of you have calculators that'll do that, and that will give you 1 1/3. But if you don't have a calculator that does that, then just take your 2x, take your 4 2/3, and change it. 3 times 4 plus 2. 3 times 4 is 12, plus 2 is 14. Divide by 2. Divide by 2. Dividing by 2 is the same thing as multiplying by 1/2. And so I get 7/3, or 2 1/3 again. Oops, it should have been a 2, shouldn't it? 2 into 4 is 2 1/3. And here, how did I get 7/3? I simply did that canceling right there. 7 times 1 is 7, 3 times 1 is 3, and so forth. Now, here is a problem waiting to happen, a mistake waiting to happen. Here's what most people will do, or a lot of people will do this. They'll take the 3, distribute it, and so they get 12 here, and oh, that must have been minus, huh? And 3 times negative 3x is negative 9x. And then, of course, this other side still is the same. What's the mistake? I just made a mistake. Can you see what it is? It's right here. This should be a plus 9x. Why? Because this minus sign, you want to move over to the 3 and replace that with a plus. Now I've got negative 3 times 4, which is minus 12, or negative 12. Negative 3 times negative 3x is plus 9x. There you go. And see, we've already made this an easier problem. So I've got 14x minus 12 equals 22x plus 1. Now, once again, people will say, well, which side do I go to? Which side do I go to here? Does it matter? Well, actually, it doesn't matter. And let's do the problem both ways. So suppose we take the 22x over here. That gives me negative 8x. And since my x's are now here, I should bring my 12 over here. And so I've got 13 divided by the negative 8, and I've got 13 divided by negative 8, or negative 1 5/8. Now, what if we went the other way? What if we took our 14x here, subtracted our 14x? So that gives me 8x. Subtract the 1 over here, and it gives me negative 13. Now notice, I'm going to have negative 13 over negative 13 over positive 8. That's the same thing as 13 over negative 8. It's the same answer. So in answer to the question, which side do I take the variable on, which side do I take the number on? Either side you want. The only thing is, if you decide to put them on both on the same side, for instance, suppose you end up going, you end up putting them on the same side, and you end up with negative 8x minus 13 equals 0. Well, now you've got to move that 13 or move the 8. So you've either got to make it negative 8 equals 13, or move the 8x over and have 8x equals negative 13. Either case, you're going to get the same answer. What about fractions? Is there a way I can deal with them? You know, for instance, if I did this, I could divide that 3 out right here, and I'd have 3x divided by 3 plus 2/3 plus 5/4 x. I could write it like that. Wow. And this would cancel. Well, that helps. And I'd have to take the 2/3 across, subtract that from 17, divide by 5/4. There's an easier way. Now, you could work them the way we just did, but there is a slightly easier way. And in that way, we'll describe with a little phrase here, clear the fractions. How do I clear the fractions? In other words, clear them, get rid of them. Notice that 3 and 4 have the common denominator of 12. So if I take this whole thing and multiply by 12, means I've got to go here, I've got to go here, and I've got to go here. Then I'll have 12 times the quantity 3x plus 2 over 3. I'll have 12 times 5x over 4, and I'll have 12 times 17. But look what's going to happen. The 3 is going to cancel into the 12 and give me a 4. Then the 4 is going to multiply through and give me 12x plus 8. The 4 is going to cancel with the 12 and give me a 3. 3 times 5x is 15x. And then the 12 and the 17 simply get multiplied, and I get 204. Now we're at a much simpler problem. You know, think about this here. Let's erase this right here. Is this right here a simple problem, or is this one simpler? Which one is more simple, do you think? This problem? If I could sneak in there and get that little chunk there without getting everything else, and I can't. Which problem is simpler right there? Is this problem simpler or this problem? And you're probably going to say this problem, because now all I've got to do is take my x's and add them together, and then subtract my 8, and I'll have 27x equals 1 equals 196 divided by 27, and I think we end up with something like 7 and something, 7 and 5/27. Is that it? Okay. Now, this whole idea of clearing the fractions, this is a real key. Let's do some more of these problems. Whoops. Now, this time, my x is in the denominator. Now, you could end up just taking the 8 and subtracting the 8 and get 3 over x equals 8. Simply put a 1 under the 8, cross multiply, and I get 8x equals 3, x equals 3/8. Doesn't always work that nice. So clearing the fractions would be maybe a better way to do it. And my denominator is x. So when I bring my x into everything, look what I get. 3 times x over x, that cancels, plus 8x equals 16x. So I have 3 plus 8x equals 16x. Take the 8 across, divide by 8, and I'm going to end up with my x equals 3/8 again. Let's do the problem again. What if I add, or a different problem, and we'll just add a number here to this side. Let's put a 4x right here. Now I'm trying to get across to you the power of using the clearing the fractions technique. And you could work this problem out. You could say this is 3 1 over x's plus 8 equals 16 plus 4 1 over x's. And then these two terms you could put together by subtracting 3 1 over x's from here. Then you end up with 8 16 plus 1 1 over x. You end up with negative 8 equals 1 over x. And x equals, multiply that out, negative 1/8. I think that's right. Now, let's do the same problem again, but this time let's clear the fractions. So I bring in the x, bring in the x here, 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 and here. So then, now let's just do some of this in our head. When the x goes into here, this is going to cancel, and I have 3. When the x goes into here, so I'll have 8x, and then I'll have 16x here, and then here I'll have just 4, because when the x goes into here, they'll cancel. Pretty nice, huh? So taking the 4 across, I get negative 1. Take the 8 across, I get 8x. X equals negative 1/8. Now, I would say this is somewhat of an easier process because there's one less step. And of course, I did do some of this in my head on the way over, but either way, kind of get the idea.